This is 9.5, Algebra 2 at Trig, working on central tendencies and dispersion. These are statistical topics. So numerical values used to summarize or compare sets of data. That's what statistics are. The two important types are the measurement of central tendency, which is used to represent a center or middle value. And then there's dispersion, which is a statistic that tells us how dispersed or spread out the data is. So these are our examples. For central tendency, showing us the center number. Average could show you that. The mean is another word for that you might be more familiar with is average. Average is pretty simple. You've done this for years. It's the sum of the numbers divided by the number of terms. There's a variable that we use to represent the average, which would typically be X bar. That's how you say that variable. So if we were going to do X bar, which is the average, that's what the bar is representing, that this means the average of these numbers. So you would take your first number, which might be called X1, plus your second number, which would be X2, plus your third and the fourth and the fifth, all the way until you get to your last number, which we'll call the nth number. So you add them all together, and you divide that by the number of the terms. Clearly the average. Median of the numbers is the middle number. When the numbers are written out in order. So you've got to list them from smallest to largest. You cross out a small and a large together, a small and a large, a small and a large, and you get to the center. If there's an odd number of numbers, you're going to have a number waiting for you sitting in the center. Nothing else to cross out, just one number, if it's an odd data set. If it's an even data set, you'll cross out the smallest and the largest, and the next smallest, the next largest, and then everything gets crossed out. So you actually back up and you take the average of the final two numbers. You'll finally get two middle numbers. And you take the average of those. That is your median. You take the average if there's an even number of data, where you don't have a final number in the middle. The mode is the number that appears most often. So if a number is repeated like 4 different times, and another number is repeated 3 different times, the one that's repeated the most is considered the mode. If you have 2 numbers that are each repeated multiple times, the same amount of times, then they would both be considered the mode. So you can have 2 modes if they're both repeated the same amount, which is the most often. The measures of dispersion, talking about how the data is spread out, a very typical one is called the range. That's your largest value. You're taking the difference or subtraction between the largest value and the smallest value. Subtract the smallest from the largest. Another one which might be new to you is called standard deviation. It's a typical difference between a data value and the mean, or the average of that data set. So you're looking at the distance between each of the data sets, and you try to get an average between that, or how each data set is from the mean, actually. And you're trying to get an average of that. So if you have a data set called x1, x2, all the way up to xn, this is what your standard deviation by hand would look like. You take your first data number minus the average, square it, plus the second minus the average and square it, the third minus the average and square it, and just keep going until you get to the last number minus the average and square it. That looks like the distance formula. x1 minus x2 squared and y1 minus y2 squared. Doesn't matter if you start with ones or twos, but so it looks just like it. But we're going to be dividing by the number of terms. That's very important. Now there's two different types of standard deviations. One divides by n and the other one divides by, I believe it's n plus 1. We're dividing by n. Okay, just like our notes say here. So when we look in our calculations, we'll have to be sure to use the correct standard deviation. This symbol here is a Greek letter called sigma. It's a lowercase Greek letter, and that stands for standard deviation. Make sense? Outlier is probably a term that you learned years ago. A value that is much larger or much smaller than the other data values. I don't consider that a very great definition. I wish it was a little bit more detailed. Like maybe if you are 2 standard deviations away from the largest or smallest number, then that would be considered an outlier. That makes a lot of sense to me. But it's just if the numbers seems extra large or extra small, that's considered an outlier. In our examples, it won't be much of a question. It'll be a number that's considerably larger, considerably different than all the other numbers. Pretty clear. All right, on our next page, we have a set of directions that talk about how to use the graphing calculator to find these statistics. And we have some directions for using Desmos to find the statistics. I find it a little bit more cumbersome to do it with Desmos, but I haven't used it a lot. I may show you some of that today. We'll definitely use the graphing calculator today. So we're going to start out with the data set below, give quiz scores for 2 different algebra classes. Find the mean, median, mode, range, and standard deviation of each of the data sets. We're going to do one set by hand and one set with the calculator. So to do it by hand, of course, we're taking our 15, 17, 25, 17, 22, 19, 21. And we divide that by 7. Now it is doable managing this by hand. I agree, it's not very fun. What I might do here is just look at the 10 spot. So we got 10 and 20, 30, 40, 50, 60, 70, 80, 90, 100. That's just using the 10s. We're up to 100. Now looking at the 1s, we've got 9 and 1, so that's worth 10. We got 5 and 5, that's worth 10 again. So that's 20. We got 7 and 7, that's worth 14, so now we're up to 34. Plus 2 is 36. So we got 136 divided by 7. If we were truly doing it by hand, without the calculator, we would say that 7 went into 13 one time. That would give us 6 left over. From 7 up to 13 is 6. Now we're going to work with the number 66. And 7 goes into 66 9 times. That is 63. 9 times 7 is 63. So that means there was 3 left over. 3/7 left over. In a lot of different calculations, using a fraction isn't super helpful the way that we're doing our calculations here. So we're looking at 136 divided by 7 is 19.42 or 43. Approximately 19 point, we'll just call it 4 for now. Huh? The median, that's our center number. So we're going to take our list of data, and we'll take our smallest number. Then we have 2 other numbers in the teens, and then a 19 even, and then a 21, 22, and a 25. Maybe commas will help separate each of those. So I've listed them from smallest to largest. To find the median, I need to cross out a small and a large together. That's one cross out. A small and a large together. A small and a large together. Now I'm left with just one number sitting in the middle, which would of course happen with an odd list of data. If I had an even list of data, I would have had an extra number left in the middle. And there we would have had to average them. But in this case, we're doing it by hand. There's an odd list of numbers, and it happens to come out nice to be just that center number. The mode is the number that repeats the most. Looks like 17 is repeating the most. So that's our mode. The range is the largest number minus the smallest number. So our range is 10. And then standard deviation. All right, here's the big one. Trying to calculate this by hand. We'll do it kind of both ways. If you're doing it by hand, you would be indicating what all your values are. 15 minus your average. Well, your average we said was like 19.4. And we square that amount. Then we had 17 minus 19.4. And then we had 17 again minus 19.4. You might get away with saying 2 times that amount. But anyway, plus 19 minus 19.4. 21 minus 19.4. Quantity squared. You got to be sure to have the parentheses. You need to be sure to have the square. 22 minus 19.4. And then we finish up with 25 minus 19.4. Then we're going to divide all of those by the number of terms. And there were 7 terms. That is all underneath the square root. Everything is under the square root. So this is where we go calculator dependent. Okay, even when we're doing it by hand, yes, we could probably do some of those by hand and maybe square them, but squaring decimals is always a pain. So we'll probably still use a calculator, but you're showing all your steps. So parenthesis, 15 minus 19.4, quantity squared. That's my first set of parentheses. My second set of parentheses is 17 minus 19.4. Oh, sorry. We're not going to say 19.4. That won't be very accurate. 136 divided by 7. That's the number we want to use. If we want to be accurate, we need to use the real number. So that is our previous number. So, sorry about that. We're going to say 15 minus the previous answer squared plus 17 minus the previous answer squared. 17 again squared. 19 21 22 and 25. You got to use the parentheses. I'm using the answer, so it's not a rounded answer. We're doing just as good as a calculator can do for us. So we got 71.71. Now we need to divide that by 7. So we've got the square root of 10.24. Which, if we take the square root of that number, we're getting 3.200765. I'll write down all these numbers so we can compare it to the real data set. One question is, how do we get the answer to come up? And you got to hit the answer button. I'm sorry, the second button. Hit the second button. You see the little arrow pop up. And then down here, you got to hit the negative button. And that'll show you answer. So it'll give you the previous number. Okay, so that's doing it all by hand. That can be a little crazy. How can we use our calculator for that? If we hit stat. Now first I'm going to clear mine so nothing else is in it. Second plus 712. I always talk about that. Clear out your calculator. No other data is in there. So stat, hit enter for edit. List number 1. We're going to put in those values. 15, 17, 17, 19, 21, 22, and 25. I would encourage you to verify that all your numbers are correct, because if you type in one thing wrong, it won't be obvious that all your calculations are wrong for everything you've done. So you want to be sure your data is correct. Either type it in slower or go back and verify. So next we do is hit stat. We go over to calc. And which one we want to use is one variable statistics. This is what my screen looks like. Some of them will look like that. Let's see if I can get this to come into. It's a little hard to see it, but anyway, it says list and it tells you it's L1. Maybe that's better. It shows you that it's L1. So if you want it not to be L1, you need to hit second number 2, and then it goes to L2. If you want it back to L1, you need to do second 1. And it's back to L1. You need to tell it where to get its data from. My calculator doesn't show anything. So it's defaulting straight to L1. So if I hit enter right now, it's going to give me the data in L1. So we got our average of 19.4. See the X bar? Calculator showing you that terminology. It even shows you the sum of all the data. It shows you the sum of all the squares of the data. It's kind of a funny one. It shows you two different types of standard deviation. We want this one using sigma. Okay, that's your standard deviation. 3.200765. And remember, I wrote out all those decimals. I wanted you to verify that it was very accurate doing it by hand. You can get the same answer. There are 7 values. That's what N stands for. Arrow tells you it keeps going down, so arrow down using the arrow button. They have a minimum value. This Q1 is the lower quartile. The median would be the middle number. We can write that down, or that is already written down, right? Q3 is considered the upper quartile. Maximum would be our 25. We could use the maximum minus the minimum to help us figure out a range. If you remember back when you made box and whiskers, you used this data. This set of data. Okay? So it shows you where we got all our values from. You can do it by hand, or you can use your calculator. So if we're going to do our third hour class, so we go to Stat, hit Enter. I'm going to go over to List 2, 1, 6 for 16, 22. Type in the numbers. You do not need to put them in order. It'll take care of that for you. I'm going to go back to verify that all my numbers were typed in there correctly, or else it won't work as I wish it would. Stat, over to Calc, number 1. Now I had my data in L2, so you need to tell it second. Number 2 is L2. That puts L2 up there. Now it's going to take the data from list 2. If you don't, it's just going to go to list 1. It won't change the answers. So my average was 20.5. My standard deviation was 2.45 or 449. My median is 21.5. My maximum number was 24. My minimum number was 16. So that's a difference of 8. That's my range. And the mode is the number that gets repeated the most. So that's 22. Pretty straightforward, huh? Is that doable? So we're going to punch out some of these numbers again. So if we hit Stat and Edit, I'm going to go over to list number 3. Type in each of these data values, being sure that I don't miss one. You do need experience typing these in, or it'll be difficult to do when you want to, and you're going to ask questions about where's this, how do I do this? I can't help you. Okay, we got all our data in. List 3, you got to pay attention to what list you're in. So we go to Stat, over to Calc, number 1. So that's one variable statistics. So we're going to use L3. So use second, number 3. Hit the second button, hit the number 3 button, and you'll see the L3 occur. Hit enter. So our average was 90. Our standard deviation down here, we got to use the correct one. 4.79 or 95. If you round that, then it pushes it up to 8 and whatever. The median, keep scrolling down, you'll get to median. Median is also 90. The mode, the number that repeats the most, was 93. And your range was the maximum minus the minimum. The two symbols we use is average and standard deviation. Those are the two symbols that we use to represent our values. We'd have to use the word range, mode, and median for any shorthand for that. Okay, so in this situation, what we're going to do is give a bonus. Give a bonus of 5 points. Now, if I had a class of 30 people, that would be a heck of a lot of new numbers to be typing in again. Probably pretty close to 30. But we can have some predictions here. If we're going to have a bonus of 5 points, if all the numbers go up by 5 points, what's the new mean? The new mean would also go up by 5 points. Because if all the data went up, the average is going to go with it. How about the middle number? If all the numbers had added by 5 points, call this 89, call this 94, 103. It would go up by 5 points also, which would be to 95. How about the mode? How about the number that repeats the most? If all the data went up by 5 points, the number that repeats the most would go up by 5 points. It would also be at 98. How would the range change? It would most definitely stay the same. You would add 5 points to your largest number. You would add 5 points to your lowest number, and that is still 15 apart. And your standard deviation, they would still be the same amount apart from each other. The same average, the distance from the mean. So notice, we had a change with the mean. We had a change with the median. We had a change with the mode. We did not have a change in range or standard deviation. We did not have a change with the dispersion of the data, but we did with the central tendency. The mean, median, mode of the new data set can be obtained by adding the same constant to the mean, median, and mode of the original data set. The range and the standard deviation are the same. They don't change. They stay the same as the original. Our last one. Here's a set of data. I'll show you how to do this on Desmos. For those of you that like Desmos. So using Desmos, we get into Desmos. For the equation, you can type any letter you want. I'm using L just for list. You got to use a square bracket. And then you need to type in the values. We had 19.61, comma. You want to be sure that you type them in correctly. That is the most common way to get them wrong. And then you close off the square bracket. I'd suggest to hit enter. And there your data is in there. That's how you put in your list. Now you need to scroll down to the bottom. And you'll see down here at the bottom, you have this keyboard. You can hide it. You can open it. And you get all the values down here. Over here to the right side, you'll see functions. If you scroll to statistics, you can get all the numbers you're looking for. If you click mean, mean popped up, and we tell it to look at L, mean of L is 20.87. I'll go back to function, back to statistic, look at median. Oh, that's not what I meant to do. Just got to know how to use it. Get used to using it. Got to turn it to L. There's your 20.795. So we can use the list of data over here. I use mean, I did median. Now, for standard deviation, this is the standard deviation that we're using. Standard dev P. Not that one. Do the one with the P. Put L in there, and you see our standard deviation. So you can do a lot of this data the same way that we use our calculator, or a very similar way, right? We can find the median, or that was the mean, the median, standard deviation. Our mode is the number that repeats the most. And the range is the largest number. $22.41 minus the smallest number. $22 0.41 minus 19.59. We got 2.82. Pretty straightforward. If we look at a graphing calculator and we type in our data under Stat, Edit, L4 has all of our data. You can read that at all anyway. It's there. It's the numbers that we wanted it to be. So Stat over to Calc. We're doing L4. Go down to Calculate. Hit Enter. We see our average. Same thing that we wrote down. Standard deviation. Using the correct standard deviation. 0.8924. 8924. The median. The mode's the number that repeats, the largest minus the smallest. It's a hard screen to read. A screen on a screen. Okay, so now these are distances apparently of a javelin of Olympics back in the day. These are meters. Well, we don't really know meter measurements quite as well. We're more familiar with yards. So 1.094 yards is 1 meter. So a meter is larger. It takes more yards than it does for a meter. So what we're going to do, we do not have to recalculate them all directly. We'll take our average and times that with 1.094. That gives us 20.87 times 1.094, and that equals 2283. We'll take our 20.795, times it by our 1.094, and we get 2275. Take our mode, 20.56, and times that by 1.094, and we get 2249. Take our 2.82 times that 1.094, and we get 3.085. And then even our standard deviation is affected by the multiple. So when each value of a data set is multiplied by a constant, the new mean, median, mode, range, and standard deviation can be found by multiplying each of the original by the same constant. And we multiplied ours by 1.094.